My name is Shiva and my roll number is H5. I belongs to electronic and communication engineering. Today my topic is time domain equation of narrowband frequency modulation. Narrowband frequency modulation. The FM signal for a sensitive modulating wave AM equation is AM cos 2 pi FMT is given. S of t equal to AC cos 2 pi FCT plus B sin beta sin sin 2 pi FMT, that's equal to A cos, let's 2 pi FCT equal to theta, AC cos theta cos B sin theta minus AC sin theta sin beta sin theta. For beta less than 1 radius, cos B sin theta equal to 1, sin of B sin theta equal to B sin theta. S of t equal to AC cos 2 pi FCT minus beta AC sin 2 pi FCT sin 2 pi FMT. The above equation defines the approximation of from narrow band FM signal produced by sensorial modulating signal. For the representation, we deduce the modulator shown in figure. Narrowband frequency modulation. Modulating wing block diagram. Modulating wing goes to interrogator. Interrogator produces product modulator. Then it goes to cycle. Here carrier signal added AC sin 2 pi FCT. That's equal to narrowband FM wave. Phase shifter carrier sine wave. This is the process of narrowband frequency modulation. This is a block diagram of a method for generating a narrowband FM signal. Narrowband frequency modulation. Note: ideally, an FM signal has a constant amplitude envelope, but the modulating signal produced by the narrowband modulator differs from this ideal condition in two fundamental respects. The envelope contain a residual amplitude modulation and therefore varies with time. For a sensitive modulating wave, the angle theta of t contains harmonic distortion in the form of third and higher order harmonic of the modulating frequency FM. However, by restricting the modulation index to beta less than 0.3 radius, the effect of residual AM and harmonic PM are limited to negligible levels. Now expand the equation 1 we have. S of t equal to A cos theta plus beta AC by 2 cos 2 pi FC plus FMT minus cos 2 pi FC minus FMT, and the f of t of narrow band signal in equation is given. S of t AC of 2 by t del of t minus t plus del of t plus t. The expression for narrowband FM in equation 2 is somewhat similar to AM for a sensitive modulating signal. For example, equation is given below. Thus, a narrowband FM signal requires the same transmission bandwidth equal to 2 FM as the AM signal. We may represent the narrowband FM signal with a phasor diagram as shown in the figure, where we use the carrier phasor as a reference. A phasor comparison band FM and AM waves for a sensitive modulation. A diagram belongs to narrowband FM wave and B diagram belongs to AM wave. The bandwidth required for FM is quite high. FM band is equal to 2 of delta F plus FM. Narrowband FM is commonly used in amateur radio in the 144 to 148 MHz VHF band and the 420 to 450 MHz UHF band, where the bandwidth required for the FM signal is acceptable. Practically, the narrowband FM system have MF less than 1. The maximum permissible frequency deviation is restricted to about 5 kHz. This system is used in FM mobiles communications such as police, wireless, ambulance, taxi cabs, etc. Practically, the narrowband FM system have MF less than 1. The maximum permissible frequency deviation is restricted to about 5 kHz. This system is used to FM mobiles communication such as police, wireless, ambulance, taxi cabs, etc. FM signal in time domain. VFM equal to A sin omega CT plus MF sin omega MT. We can see that having a sine function with another sine function is a such more complex to evaluate than additive term of AM. Let once again see equations. The above equation 1 defines the approximation from of narrow band FM signal produced by Sensible modulating signal. For the representation, we deduce the modulator shown in the figure. This is the block diagram of method for generating narrow band FM signal. The bandwidth required for FM is quite high. FM bandwidth equal to 2 delta FM plus FM. Narrow band FM is commonly used in radio in the frequency range of 144 to 148 MHz VHF band and the 420 to 450 MHz UHF band, where the bandwidth required for the FM signal is acceptable. Practically, the narrowband FM system have MF less than 1. The maximum permissible frequency deviation is restricted to about 5 kHz. This system is used in FM mobile communications such as a police, wireless communication, ambulance, taxi cabs, etc. FM signal in time domain. FM signal in time domain, the equation is given as VFM equal to AC sin omega CT plus MF sin omega MT. We can see that having a sine function within another sine function is such more complex to evaluate than the additive term of AM signal. Thank you.